Okay, today's problem is the minimum common value. What is given in the problem statement? Like two integer array nums1 and nums2 will be given. Uh, it is already sorted in descending ascending order, smaller or lower value. So we have to find the minimum integer, find the minimum common integer in the both array. If there is no common integer, we will return simply -1. So note that integer is common to num1 and nums2 if it represent the both arrays at least one. Okay, so let's see the case. Let's see some examples. Okay, let's see this example. First example, let's see this one. Here you can see what are the common elements like in these two array. By visualization, what could we see? Like what are the common elements? 2, 3. Here also 2, 3. These two are common. Okay, so these two are common. 2, 3 and 2, 3. Fine. And so what is the minimum? What are the minimum common elements? What is the minimum? 2 is the minimum. The answer of this in this case is 2. Okay, so answer of this case is actually 2. Okay, so let's see here. What is the common element minimum? Let's say here 11 is 11 and 11. So these two actually nothing but a single element. Like we have to find out the minimum common element. As it is like at least it should present at least one. It may present 2 times, 3 times, a number of times. It doesn't matter if it is present, and if it is present in the both cases, it doesn't matter the number of occurrences. If it is present in the both two arrays, then that is a common element, and that should be the minimum. So here you can say these three is not present, even these four are not present in the above array, and these three is not present in the below array. So only 11 is a common here. So answer of the question is 11. Correct. So let's see the last case. Here if you see it should not be 11, should be 13. If it is 13, now see this. In this case, nothing is common. Nothing is common actually. Nothing is common. So in this case, answer is -1. So if nothing is common in two arrays, then return -1. So how could we do that? Like what are the approach we could take to solve the problem? First, the thing is the brute force approach is what? Just checking here for each element, checking this element, checking this is present or not, and checking this element it present in this or not. So checking this element it is present or not, checking this element present. Like checking this element and take this one array loop, iterate each and every item, check whether it is present or not. Take this element and iterate this, it is present or not. If it is matching, then fine. What is the minimum number? Like even you can start from this array or this array. Minimum, if it is 2 here, then you should this is the case, it should be minimum. The question it is mentioned that it is sorted array. So it doesn't matter you start from this array or this array. So the probability of matching, it will be from the start, whatever the first two elements is similar, it will be the minimum element. So I can start this and check this, what is the common, this is common, so I'll return. Or I can start this, I can check this. Is there any common? No. I can go next one. Is that the common? Yes, you can say this is the common. This is the common. So I'll return this kind of thing. So I can write the brute force here. But the thing is, why to write brute force? The question is, it is given like array is sorted. Array is already sorted. If sorted if array is already sorted, two arrays are all both are sorted. If both are sorted, and we want to find an element in a sorted array, so what are the best approach we could take? Obviously, we should take the binary search approach. This is the best approach we could take, binary search approach, right? So here we will use binary search approach. Like we will start from here, like any element. Here we can start from 1, and we will approach binary search to check like whether it is present in this array or not. We will come in the middle, we will check here, then it will say no, it is not present. Correct. So then I'll come here, then I'll apply binary search, it will come in the middle, then it middle means here it is 3, it will come check here, no, then it will middle like left right shift, and it will find that 2. So this is how we work. This is how binary search work. So using the binary search, it will reduce my time complexity. So because if I iterate here and then for this element I can start all the cases, then my time complexity is n into n. So big of n square, right? But if I do here and apply the binary search, it will be n. For this array, it will be n. Okay, let's see first write the pseudocode, and then we can see how could we minimize the problem. Okay, like what is the time complexity regarding that? So I am writing that find function. What is the name of the function is binary search. Find minimum. It is a find minimum. Find common. Find common. Okay. What is given? Nums1, nums1, and nums2. Okay. As usual, what do you need actually whenever we solve any kind of array problem? So length. So let's say n is the first array length. So arr or nums1, nums1 dot length, and n is nothing but nums2 dot length, nums2 dot length. Okay, that I could take, and after that what could we do? So as I told you, I have to iterate each and every item from the nums1 or nums2, doesn't matter. You have to take one item for nums1 and another nums2. So I can take nums1 and nums2, and so I have to iterate for each item in nums1, like for item belongs to nums1. Okay, I guess you get it. For item in nums1, so I'm saying for each item, if it is the case, so let's write in different color. Nums1, if that is the case, then I'll do, if I have to check whether it is present in the nums2, correct, whether it is present in the nums2. So I'll search simply one binary search here, like if, let's write a function bs nothing but binary search. I want to binary search on what nums2, and what I am to search item. If that is the case, if it is true, that means I found a search, and as I told you, I can start from the first, and whenever I am finding them, as I can assure you, like this is the first non-minimum, because the two arrays are sorted. Even if I can search from here, and if I found that element is already present in the nums1 array as well, I can say this is the minimum. So I can return whenever if it is true. If it is true, then I can simply return true. Return not true, like what I have to pass what is a common element. So here it is item. The item is present in the both of the cases. So if it is the cases, this is I will stop. And at the end of the function, like if anything is present, then it will return. It should return from this area, right? If nothing is returning from this area, that means nothing is present. So in that case, at the end of the loop, I will return -1, because nothing is present. Okay, so I hope you all know the binary search function, but I'm writing now. So let's say function binary search. What is given? One nums array and one is item, or let's say x. I have to find x in the num array. So what I will do in the binary search, we need left and right. Left equals to 0, right equals to nums dot length -1, nums dot length -1. That is what we do, and after that we need a while loop. While my left is less or equals to my right, that's what we do. we need, what do we calculate? We calculate mid. So mid is nothing but left plus right minus L divided by 2, that we calculate. And general case, like if general case is if my nums of mid is greater than my target. So nums of mid is greater than my target. That means what? My target is said is present in the left side of the case, right? If that is the case, what do we do? We simply write the assignment like right will be my mid minus 1, mid minus 1. Okay. Else if that is not the case, else if nums of mid is less than my target, that means mid value is less than my target, so target must present on the right side of the array. So I reassign my left equals to mid plus 1, correct? And other case, like if it is similar, then what? Then I found the target, right? Else if it is similar, then it means I found the target. So simply return what? Return true, correct? If it is returned true, that is the case. So this is where my loop ends. And but if doesn't return true inside the while loop, that means what? It is not present. So in that case, I will say return false. Return false, and end of the binary search. So what case? In this case, what is the time complexity? It is returning for what? Big O of m time. For each item I am reversing this big O of m. For each item, binary search takes big O of log of n times second size of the second error. The time complexity is m into log of n. So this is the time complexity. Space complexity is nothing but, am I taking extra space? No, that's a big O of 1. Big O of 1. This is the time complexity, space complexity of this problem. And there is one small trick, so let me tell you as well. Like if assume my n is very greater, my m is very small. Sorry, my m is very greater, n is very small. So what we could do, like let's assume m is 60, this amount, okay, and n is 100. In that case, better to like log n is much better than normal element, right? So I can swap nums1 and nums2. So I can write 100 and then I can calculate 1000. It will be much better. So not 1000, it is 100,000, 1 million, I guess. So that will be much better. So I will calculate here. Just one small step you have to write in this case. Just one small step. We have already calculated my n and m, right? So in this place, just write one line. If my m is greater than n, I will simply call the same function. I simply call the same function find common, and what I will pass, I'll just swap this nums2, because see, nums1 is higher element and nums2 is lower element. So I'm passing less element nums2 comma nums1. Nums1. So this is what I have to do, just fill one line. If it is the case, I will just swap the case and again run the function. In that case, m becomes n becomes in, it will be swapped. So right now, in next case, m will be the smallest, and then time complexity will be much lower than the first one. So this is required. This step is required when m is very greater than n actually. So this is very greater than n. Doesn't matter if I get c, like if it's greater than n, I will swap this value. Somehow it will improve some, like a small amount of time complexity. Okay, this is one step. This is one approach. What is another approach we could take? Let's take this example and copy it. In this example, what could we see? Like one thing we could do, we can use what approach we could do? We can use two pointer method, this one and this one. So this is I and j. I will check in nums of I. If it is equals to nums of j, that means it's same. So I will do it. If my nums of I, like this, if nums of I is less than my nums of j, in this case, what I will do? I will increment this nums of I and check whether they are same or not. Hope you get it what I am want to say. Okay. So, and in that case, after that, if again nums of, we say nums of I and nums 2, like nums of 1 of I and nums 2 of j, if it is same, if both are same, we will return. If both are not same, we will see what will happen. Okay, let's give you an example. Give a good example. Let's say here it is 2, this is 3, this is 4. Okay. If I take this example, so here what will happen? So fast as well, as earlier I will initialize I and j here. So here it will be I and it will be my j. So first I will check my I equals to j or not. No, not same. Is I less than j? Yes, I less than j. So I will move this I to next place. Again I will check if I equals to j or not. It is same. Is it same? No, it's not same. But j is less than I. So sorry, because nums2 of j is small. So this point I will move here. Now I'll check this two case. What is like ith position is smaller, then I will move I. This is how we will move. I will come here, and then j will come here. J will stay here. Now you can see like j is smaller. If j is smaller, I will update j. Again j is smaller. Again I will update again j is smaller. Then I will update j. This is how we will reach. After that, I can see I is smaller. I is smaller, so I will update I, and at this point I and j are equal, so I will stop. Hope you get it. Like this is how we do. So in this case, if it is not case, if anything is gets out of index, if anything is gets out of index, we'll stop. We'll stop. So for an example, give this one. Give you an out of index example. So here what we'll do, let's I and j. Here I and j. You can see j value is less than ith value. So I will update. J. So here also in the when I'll update j, here also j value is less than my ith value. So again I'll update j. Correct. Here also the same. Like when I update j becomes in the 4. Here also j value is less than ith value. I'll update j. Now you can see ith value is less than jth value. So I will update I. After that again ith value is less than jth value. Then I'll update I. Now you can see now jth value is less than ith value. So I'll update j. And now again jth value is less than ith value. So j becomes out of index. So at that step we could stop. So using this two pointer method also we could solve the problem. So what is the best case? Best case is this. So let's write the code. In this code, what we are going to write, like function find common nums1 and nums2. Okay, and what do you need? We need fast, like we need uh, two pointer only. So two pointer I and j. So I mean initially this is 0, correct? And like up to when I have to iterate until I less than my first nums1 and j is less than my length of nums2. If anyone crosses the limit, I'll stop the iteration. So what I have to do, I have to write a loop while my I is less than my nums1 dot length. Nums1 dot length. If that is the case, and also j should be also less than my nums2 dot length. Nums2 dot length. If both are the cases, I can iterate. And iterate what I have to check? Simple as I told you earlier. Fast check if my nums of I, nums1 of I is less than my nums2 of I. If that is the case, what we will do? I'll increment I plus plus. I'll do I plus plus. If that is not the case, if nums of I is greater than my nums of j, what we will do? I will do j plus plus, correct? So in that case, if what is the case? If it is not the case, else if it is greater than, so I will do what? I will do only simple j plus plus, and if both are the case, if both are same, else if it is both are same, so we'll simply return the anything. So return either nums of I or nums of j, doesn't matter because both are same actually. Nums one of I or nums2 of j, it doesn't matter. You can say return anything. But if at the end of the loop it is iterating, and at the end of the loop nothing is same, if it is nothing is same, so then what I have to do? I have to simply return -1, because I I've already iterate over one first array, one array of second array, first array of second array. So I didn't find any single thing that is common. So I am returning the -1. So there is nothing in common. So in this case, what is the time complexity? So it at maximum it can. If you see this case, if you see, so finding this element, I'm covering kind of, I'm rotating at like these cases, like up to this part of the array and up to the whole part of the array. So it is nearly n plus n. So it could be possible like only last element of my match. As the last element I'm finding the match. Here could be, let's assume it's 11. Assume it is 11. So if it is 11, so it is the last index I can get a match. So I is traversing from 0 to say it is a m and this is n. So I is traversing 0 to m and j is traversing 0 to n. So it is m plus n. So that's why it is traversing. So it's big of m plus n. Okay. And is it taking any extra space? No. And these all cases are what big of 1. This is normal case, like constant time complexity will take. The time complexity is becomes here big of m plus n, and space complexity is big of 1. Simple, because I'm not taking extra space. Hope you will get it. Let's see another easy. I'm not say easy, but it will be. Let's say another approach. What we could say. What we could take in this approach. What could we take? Take this example. The example we could take, like, see, there are like there could be only occurrence of each digit could be one or multiple, doesn't matter how many occurrences. What I could do, we can take the set, we can make the set of it. Set, I can take the set. Here also I can take the set, and after that taking two of this set, we can do what? We can do like we can do intersection. We can do intersection. Okay, we can do intersection. And this intersection, if there is any common, we have to find the minimum of the intersection element. Hope you are getting it. Like, what is the intersection of this? Like, what is the set? What is the set value of the this case? This set value of this case is 2, 7, 10, and 11, right? What is the intersection of this set value? Its intersection is 3, 4, 8, and 11. Sorry. My bad. So this is the set value. This is the set value of the first array. This is the set value of the second array. So now if I do intersection, what is the value of intersection? If I do set intersection means like what is the common element in both sets? So this is the common element. So 11 is the most common element. So if I see here, what is the set value of this case? 1, 2, 3, 4, nothing. Set value of this one is also 2, 3, 4, 5. Correct. So what is the intersection value of these two cases? You can say intersection value are 2 and 3. So 2 and 3. What I have to return? I return the minimum. I can return the minimum of the intersection value. So this is how you can. So here, what is the intersection value? What is the set value of this? The same thing, 5, 7, 10, 11. And what is the intersection of this value? Is value is like 1, 2, 4, 8, 9. Sorry, not intersection, set value of this set value of this array. So what is the intersection value of now this set 2? You can see there is no common element. So intersection is actually 5. Nothing is present. Null. You can also say null. So this is the thing. So this is the simplest. You can say like that. So how could we check? How could we write the code? So first of all, I need one set one. So let's say again function find common nums1 and nums2, nums1 and nums2. In this case, what it is nothing but what I can say, nums1 and nums2, and I have to find a set. So set 1 equals nothing but set of nums1, set 2 equals to set of nums2. Okay, and what I need the intersection, right? So I need is3 new set, which is nothing but set 1 dot intersection of set 2. So I'm writing the pseudocode in your respective, whether you are in Python, C++, C, Java. In pseudocode, there is some function should be there regarding your hash set or set, order set, anything. Order set doesn't. You can just simply take set. Order set or set, it doesn't matter. So find the use the function. There should be some intersection function. It should be there. So use that intersection function. So intersection of s2. Okay, so this will give us the s1 intersection of s2. Now what I have to find it out? I have to check whether, now the thing is, this could be empty or it could be some value. If it is some value, I have to find the minimum value. If it is empty, I'll return null. So I will simply check, like, if my s3 dot is empty. If it is empty, then I will do what? I will return -1, like nothing is common. So return -1, -1. But if it is not common, else, sorry, if that is it is not empty, else we'll return what? We'll return minimum of s3. What is the minimum? It could be many item could be present, right? Will minimum of s3. So this is what we do. Okay, what will be the time complexity? Time complexity converting this set into the set is big of, let's say nums1 is length of m, so it is big of m, converting take m amount of time, this converting will takes n amount of time. This intersection is like at worst case all items are what is this, all items are same, right? All items are same, like this case, like this case, all, like all numbers are unique. All numbers are unique. In all number of unique, that is a set is a nothing but the actual array. The set like it is a set, but set it is containing actual whole all elements of the array. These are also all elements of the array. So intersection will take m plus n time. So anyhow, it will internally it will approach this kind of it will do this kind of approach. It will compare two elements and it will say like what are the elements are common. So it will take big of m plus n time. It will take order of big of n plus n time. So what is the time complexity? Time complexity is big of m plus n as usual. And space complexity, here I am taking Mr. Space. I am taking m and n, and as told you as a host case, it will be exactly similar to the length of my arrays. So that will be also big of m plus n. Okay, I hope you get it. So these are the some approaches you can solve this kind of problems. So I told you like I try to tell all of this. There could be many other approaches as well, but these are the most common approach you can use. So this is the end of the video, and as always, if you find any mistake in this video, because I do many mistakes, so please let me know so I can rectify. And if you find anything useful on this given topic, please also let me know so that I can learn. Thank you. Bye bye.